Good day, students. You are on to Dr. OJ's tutorial class. In this video, we shall be talking about limits. Stay blessed as you watch and listen. Please don't forget to click on the notification button so that each time I upload new video, you'll be duly notified. Thank you. Now we go to limits. Let's define the concept called limit first. Let f of x be a real value function. Let f of x be a real value function. Okay. The limit of f of x occurs as x approaches a certain number, a certain value, a certain number. Say a. Let's use a as the number it approaches. If the corresponding values of f of x approaches a particular value, say L. Let's say L is the value. So mathematically, this can be written as the limits of f of x as x tends to a, is equal to L. That's it. The limit of f of x as x tends to a is equal to L. Let's quickly consider some relevant example. To buttress our definition of limits. Let's consider some relevant examples to buttress our definition of limits. Okay. Now, example 1. Evaluate limits of the function x squared plus 2 as x tends to 3. That's the first question. The second one, evaluate limits of 1 over x minus 2 as x tends to 2. So now let's quickly solve this. The first one is limits as x squared plus 2, limit of x squared plus 2 as x tends to 3. What you need to do is what? You assume your x approaches 3. So in that case, 3 will represent x. So you have what? 3 squared plus 2. And that is 9 plus 2, which is equal to 11. Now for the second one, that solves that problem. For the second one, number 2. Now you observe we have what? Limits 1 over of FL of 1 over x minus 2 as x tends to what? 2. Here, it will be relevant and appropriate for us to find both the left hand limit and the right side of the limit. So what do? We say let's start from the right hand side. Limits as x tends to 2 plus. The 2 plus here, it does not mean plus 2, please. It means that you are starting your limit from the right hand side. So that's what? 1 all over 2 minus 2. So that will give us what? 1 all over 0. Okay? And so that will give us what? Infinity. It's undefined. But this infinity is positive 1. Why? It is a positive infinity because we are starting from the right hand side. Now, suppose we start from the left hand side. So we have what? It will limit as x tends to 2 minus. The 2 minus there does not mean minus 2. It means that you are taking your limit from the left hand side. So you have what? of 1 all over x minus 2. That will be what? 1 all over 2 minus 2, which is also what? 1 all over 0, which gives you what? Infinity negative. That is negative infinity. They give you negative infinity. Why? Because we are starting our limits. We take our limit from the left hand side of the function. So, and 1 over 0 is undefined, just like this one. It means that since the limit is taken from the left hand side, it will be negative infinity. So that solves the problem. Now let's look at some of the properties of limit. Some of the properties of limit before we move on to solve more questions on the limit. What are the properties of limit? We need to know the properties so that each time we come across questions on limit, we'll be able to solve them easily. Now we go to properties of limits. Properties of limits. Properties of limit. One, the first property of limit is the limit of a constant c as s tends to a is what? Is equals to c. This c is a constant where c is a constant. Where c is a constant. You know when we say a variable is a constant, that's a value that doesn't change. So if you are taking the limit of a constant as s tends to a, obviously you see that x is not a variable here. So that's why we have c. Is c going to be the constant? S is absent. Now, limits of x as x tends to a obviously will be, it means that as x approaches a, you want to take the limit of x, the result will be what? A. That's all state. So you are taking the limit of x. When x approaches a, it means that when a replaces x, you have a. The third one. And the limits as x tends to a of x raised to power what? N. So just like this is just, you know, the nth degree of the first one. That will be what? If your s tends to a, it means what? A raised to power n for any positive value here. For any positive value here. Let's look at the fourth one. The fourth one. Limit of c dot f of x as what? As x tends to a. Now, just as simple as the other one you've done. Don't forget that this c is a constant. That c is a constant. So you can bring out the constant and say c dot limit of f of x, the factor that c out because it's a constant, as s tends to a. Okay? And that will be what? C dot, you know. Now, if s tends to a, you are taking the limit of f of x and x tends to a. It implies what? F of a. So that the result is c dot f, or you can say c f of a without putting dot. It's okay. You're still right. C multiplied by f of a. Now, let's look at more advanced properties. Let's look at some more advanced properties of limits. Let's look at some more advanced properties of limits. Let's look at some more advanced properties of limits. Okay. Now, some more advanced properties of limit. We have, let's say, limits. That's number 5. Limits of a function f of x plus or minus d of x. So, as x tends to a, you know, just you break it as limits of f of x as s tends to a plus or minus limits of g of x as s tends to a. Because limit is a linear map, so you can break it up, you can split it, you expand. So this one what? As s tends to a, you have what? F of a. This one becomes f of a plus or minus g of a. The plus or minus here means it can occupy, it can have a plus sign, it can have a negative sign. So that's just that. Now the sixth one. Limits, this is the product of limits of two functions of f of x dot g of x. Suppose we have this. So what you just need to do is split it. Limit f of x, don't forget as s tends to a, you know, limit f of x as s tends to a multiplied by limit g of x as s tends to a. So, and that will give us what? That will give us what? F of a dot g of A. That solves that problem too. The next one, the next property, we have talked about the addition and subtraction of limits. Now we have talked about the product of two limits. Now let's look at the rational functions. The one that involves division. That's number 7. Limits of f of x all over g of x as s tends to A. It's just the same method, just, limits as s tends to A of f of x all over limits as s tends to A of g of x, provided g of x is not equal to 0. Because if it is 0, there will be issue. That means it will give you what? It will give you, let's say, where the limit of, let's write like where the limit of g of x as s tends to A is not equal to 0. If it is equal to 0, you have an undefined value. So this one got limit as s tends to A of f of, that's f of A all over as s tends to A become what? G of A. Now the last one here before we go to the next stage of solving problems concerning limits. Now, which is number 8, we have limits of the square root of f of x as s tends to A. So you can have it as the square root limits as s tends to A of f of x. Yes, because it is possible for you to, like I said, it's a linear map, so you can multiply out by putting it inside the bracket, provided limits of f of x as s tends to A is positive, that is greater than or equals to 0. Because if it is negative, you cannot find the negative value of the square root, because we are talking about real numbers, not complex numbers. So that will be difficult. So in this case, we can have what can now say the square root of what? F of A. So on this note, we are going to stop here. So in the next video, we'll be looking at how to solve some problems concerning limit. Stay blessed.